Okay. So what we're getting into is shapes of graphs. Okay. Today is the first day of it, and we're going to focus on the symmetry of our graphs. Okay. Symmetry, mirror image. Okay. Where does it reflect? And it's the same on both sides. So on our warm up today, it says use the graph to estimate the x and y intercepts of the function and describe where the function is positive and negative. Okay. So let's start with what it asks first, the x and y intercepts. So an x-intercept is where it crosses the x-axis, okay? And my x-axis is this guy right here. So where is my parabola crossing that x-axis?
3 and negative 4.
3 and negative 4. Good. So we have x-intercepts at negative 4, 0, and 3, 0. Good. 2 spots. All right, the next question was, where is it crossing the y-axis? So my y goes up and down. It's this one right here. Where is my parabola crossing the y-axis? About down here? Right here? What is that?
That's 12. That's negative 12.
It's going to be 0 and negative 12. Good. So remember, my x-intercepts have a y of 0 because it's only your x that we can see. All right? Your y-intercept only has a y value. Your x is 0 because we can only see the y value. Okay? All right, next. Describe where the function is positive and where is it negative. So this is all review from our last test. So remember, positive means we are above the x-axis. So we're looking on top. Do we have 1 or 2 pieces that are positive? We have 2 separate pieces that are positive, right? We have this side and we have this side, and it matches the x-intercept. So on the left side of negative 4, or less than negative 4, and then greater than, or to the right of 3. Those are your positive intervals. When x is less than negative 4, and when x is greater than 3. So remember, your symbols literally point those outside pieces. All right, and then the last thing it asks me for is my negative. Okay, so when I'm looking negative, we're looking under. Okay, there is one piece under my x-axis and it loops down, right? It's in between my x-intercepts.
What?
So we are negative. Come on, there we go. When we're in between negative 4 and 3, right? Oop, dropping the pen. Negative 4, x, and 3. So when x is in between your x-intercepts, it's showing it's in between those points. That's where it's dipping down. Or sometimes it'll be like popping up above. Okay. I know I have one eye, but I can still see your cell phones. So please put them away. Thank you. Please be respectful. What's up?
How do you have one eye and still have better handwriting than me?
I'm really concentrating.
Be quiet. I'm Carrier.
Okay. So this was a review over the last little bit that we did. Do y'all have any questions before we move forward? Do you have any questions before we move forward? All right. The graphs of some functions exhibit key features called symmetry. A figure has line symmetry in the y-axis or some other vertical line if each half of the figure on either side of the line matches the other side exactly. So in a parabola, that line of symmetry is at the vertex. Okay? So drawing a line through the vertex shows a line of symmetry when it comes to our quadratics. So keep that in mind. Okay? All right, determine whether each function has line symmetry. Explain. So my first graph right here, can I cut that in half anywhere, like it was a piece of paper, and fold it, and it like match perfectly?
Yes.
On the first one?
Oh, no.
On this one right here? No, we cannot. Okay, this one does not have any line of symmetry. Okay,
No,
this is
no symmetry?
This is no symmetry. Okay, there's nowhere that I can vertically cut this in half and it folds on top of itself. I cannot. Symmetry. No symmetry. Right? How about the middle one? Is there a place I could draw a vertical line, almost like a mirror, and both sides reflect over themselves? Yes. Okay? I could do it. If I cut through right there, do you agree both sides are the exact same? Yes. So this has a line of symmetry. Okay. It didn't ask for it, but it's specifically where x is 1.5, right? That was where we drew our line. That was where we cut through the x-axis.
Oh, I see what you're saying now.
Okay, good. All right, how about this guy?
Yeah, you can. Not. You cannot.
Yes? No?
No. No.
Yeah, I would say no. I was trying to do like a diagonal, but I don't think that would work either. So yes, no.
That's one you can now.
No symmetry for that one. The next one you can? All right, where can you do it?
You can like cut it in half and then like fold it onto each other.
All right. What x value is that happening at?
1.5.
1, 2. This one's at 3. Yeah. Okay, so this is a yes. All right. We good?
That scammer just texted me.
I'm sorry. Y'all have questions for me? Where do you think you can draw a vertical line and cut it in half perfectly? What's the middle? Like that? But it's not the same on both sides. If I were to fold that in half, this piece would go over here and this piece would go over here. It wouldn't go on top of itself. Yeah, it has to like fold on top of itself. Like a mirror. When you cut it in half, that's like a mirror. So both sides should be reflected on each other. All right. Interpret the symmetry. So a fountain is spraying a stream of water onto the air. The solid portion of the graph represents the path of the water, where x is the distance in feet from the fountain and y is the height in feet of the stream. Find and interpret any symmetry in the graph of the function. All right. Is there symmetry? It's a parabola, so that always does. Where is it happening? In the middle. Okay, so when you say in the middle, what number does that associate with?
I'd say in the middle is...
When you cut it in half, there you go, it's at 2.
Who's at 8?
So 8's like close to the maximum, but it's not going to be the symmetry. Okay, so here, so when x equals 2, that is the symmetry. How can I interpret that? Well, we're talking about like a fountain. Yeah, how? Okay, what does that mean about my fountain?
That it's...
What's happening at 2 seconds?
It's going up and then going back down.
Good, that's when it changes direction. Good. Because it's also my vertex, right? So this also shows that it reaches its maximum. Reaches max height. Can't see. At 2 seconds. Because that's when it changes direction. So the water fountain shot up, and then it falls back down. That symmetry shows you where it reached the maximum height. Okay. What if I asked you what is the maximum height? What would you tell me?
8.
Around 8-ish? A little bit more?
8.5.
Yeah. Good. Good.
When you ask where's the middle, I thought you were talking about like the number of sides.
Oh, okay. You're good. How are we feeling so far? Is there a back? There's a back to this, isn't there? There is no back to this? Not today? Okay, cool. Beautiful. So, we got one more. Hey, lovelies. Hey, lovelies. This notes today is only a front page. So, we're almost there. So, stay with me so we can finish. So, you can go ahead and get a stamp for today and so we can work on our assignment. All right? Here we go. The graph represents the height, y in feet, of a golf ball hit off of a platform as it travels a distance of x feet. All right. Use the graph to describe any symmetry of the graph of the function. Okay, so look at my parabola. We know parabolas always have symmetry. So where is it happening? I wouldn't say at the 100. If I were to cut this in half, right? Would you agree that I'm on the right track? Cutting it in half. Okay. I would say about 90. That'd be okay. Listen. So do you see how your blocks are counting down there? They're going by 25s, right? So 25, 50, 75, 100. So we know it's in between 75 and 100. So some of y'all guessed about 90. That would be fine. 85, 90, somewhere around there. Okay. So let's say when x is about 90, that's when we have the symmetry. What does that mean about the golf ball? So it says x feet. So this is horizontal feet, right?
So it went up 90 feet in the air.
It did not. It went out 90 feet. So the x is the horizontal distance. Yeah. So it reached max height at 90 feet horizontally. Can y'all read that? Y'all listen, please. It reached a maximum of 90. It reached its maximum height after it traveled 90 feet horizontally. Is what that means. We guessed. Yeah, it could be. You could say 85, 90. Any of that would be appropriate. Yeah. Right. So in between 75 and 100. All right. So which one of these are we going to check off for interpreting? Because we kind of did it already. Which one of those matches what we were trying to say?
The one that said 90 to 80.
The height of the golf ball when it has traveled a distance of 0 to 8 feet is the same as the height of the ball when it has traveled a distance from 8 to 28.5. Hold on, let's go through each one. Let's see. The height of the ball when traveled has a distance 0 to 8 is the same from 8 to 25. Okay, so 0 to 8. Yeah, definitely not. No. Okay. The height of the ball when it has traveled a distance from 0 to 90 is the same as the height of the ball when it has traveled a distance from 90 to 180. So it's saying 0 to 90 is the same as 100 to 180. Are those the same on both sides? I mean, I kind of like this one. This is showing that both sides are the same. Okay? Y'all, please stop talking. Please. Okay? You're going to get confused. There are lots of words happening that you need to hear me say and not what you are saying. Okay? Again, so far I like B because it said the golf ball when it has traveled a distance from 0 to 90 feet. Okay, so when it has gone 0 to 90 feet, 0 to 90, it says it's the same height as going 100 to 180 on this side. I like that. Those are symmetric, okay? But let's just make sure. The distance of the golf ball when it has traveled 0 to 8 feet in the air is the same as the distance as the golf ball has traveled when it is 8 to 28.25 feet in the air. Okay, so now it's saying that the x's match those y's. 0 to 8. Let's see, what is it talking about? So 0 to 8, they're saying that is the same as 8 to 28.5. Yeah, I would say no. I do not agree with that. Nope. The distance of the golf ball traveled when it's 0 to 90 feet in the air is the same distance as 90 to 180 feet in the air. Okay, so that one was almost it, and some of you picked that one. The issue is it's saying in the air. So that's reflecting the y coordinates, and that's why we don't like this one. Okay, because it's 0 to 90 feet traveled, not up in the air. Does that make sense? So that's why D is not the answer, but B is. Traveled is horizontally. Yep, traveled is horizontally. And then the height would have been the y's. All right. It is a stamp day. Yeah, so make sure these stay out. I'm going to come stamp you while you're getting your Chromebooks ready.